Okay, we are continuing on with Unit 7. This is our last video for Learning Target 7a, Properties of Exponents. So in the prior two videos, we talked about each property of exponent. We went through all 7 of those properties. They're listed for you for reference over here on the right-hand side of the screen. What we're going to do now is look at examples that could combine more than one of these together at a time. So make sure you're really strong with all the examples we went through in the last two videos first, and then we'll combine these with some more complex examples in this video. So our instructions for all of these are simplify the following without any negative exponents. So let's look at example A. It says 6 times m to the second times n to the fourth over negative m to the fifth over n to the third. I think it's really helpful to go through and think about, well, what are all the different pieces that I have going on? So I have an m to the second in the numerator. I also have an m to the fifth in the denominator. Well, those can eventually get combined together because they have the same base. Remember, anytime we're dealing with exponents, the only way I can combine them together is if they have the same base. Likewise, the n to the fourth and the n cubed will be able to get combined together as well since they have the same base. The last thing I have to worry about is, well, what happens with the coefficients? I have a 6 and I technically have a -1 in the denominator. Am I able to combine those? Yes, we are. So I'm going to break this apart into each one of these. So we have 6 divided by -1 times m to the second over m to the fifth times n to the fourth over n to the third. That way we can really see each one of these pieces of it. And let's simplify each individually, and then I'll multiply them since they're multiplied to begin with. So 6 over -1 will give me a -6. When I have a m to the second over an m to the fifth, that's using our rule number 5 over here where it says I subtract the exponents if I divide powers with the same base. So I'll end up with an m to the -3rd since I have 2 minus 5. And I can do the same thing with the n to the fourth over the n to the third. Because I have the same base, I will subtract the exponents. 4 minus 3 will give me an n to the first. The last thing I have to do is I've simplified all the way, but I have to get rid of negative exponents. So to get rid of our negative exponents, we know that we can flip them down to the denominator and rewrite them as a positive exponent, and that would be our second property. And I only do those for the pieces that have negative exponents. So how many pieces will I end up flipping down to the denominator? We'll have to only flip 1. We'll just flip the m to the -3rd down to the denominator since that's the only part with a negative exponent. So -6 is a negative number, but its exponent is positive, so it will stay in the numerator. Actually, let me write over to the side so I have enough space. So we'll end up getting -6 times n to the first in the numerator over an m to the +3 in the denominator. And that will be our final answer for example A. Okay, let's look at example B. So example B says 4 times a to the 7th over x to the 3rd, all raised to the 2nd power. So the first thing I want to think about is, can I simplify anything inside the parentheses? Because if I can simplify stuff inside the parentheses, it's going to make my life easier later. Well, in this case, I have 2 different bases. I have an a and an x, and because the bases are different, I can't simplify anything. So the next thing I have to do is, well, I have to worry about this second power on the outside. How many pieces will we distribute that second power to? We will distribute that second power to 3 pieces. I'll have 4 to the second. We have a to the 7th to the second, all over x to the 3rd to the second. So remember, there's 4 different pieces inside of here. The 4, the a to the 7th, and the x to the 3rd. So each one of those has to be raised to the second power since they're all inside the parentheses. Now I get to simplify. So 4 to the second we know is 16. And then a to the 7th to the second, because I have a power to a power, that's what rule 4 says, I would multiply those exponents and I'd get a to the 14th then, because 7 times 2 is 14, all over, again I have power to power, so I will be multiplying those exponents. 3 times 2 will give me a 6, and we'll get x to the 6. Since I have no negative exponents and I've combined all the like terms that I can combine, I am good to go. Okay, let's look at example C. Why don't you guys pause the video and try example C on your own first. Okay, so let's check this third example here. So I have quite a few moving pieces. I have coefficients on both the numerator and the denominator, so I'll want to eventually combine those together. I have an a to the negative third in the numerator, and I also have an a to the fifth power in the denominator, so those will be able to get combined. And then I have these b's, b to the seventh and b to the second, which will be able to be combined. This example C is really similar to example A. So I'm going to go ahead and break that apart like we did in example A, and get negative 3 over 12 times a to the negative third, a to the fifth, b to the seventh, and b to the second. Now, if you were stuck with where to start with example C, this is a very good technique so that you can really see each individual piece and simplify those and then multiply them all together at the end. Okay, let's look at the coefficients. So negative 3 divided by 12 would give me a negative 1/4. When I have powers divided by the same base, so the same base on both the numerator and the denominator, I will subtract those exponents. So I'll get a to the negative 3 minus 5. I'll do the same thing with the b's, and we'll get b to the 7 minus 2. So I'll end up with negative 1/4. We'll have a to the negative 8th and b to the positive 5. The last thing I have to worry about here is the negative exponents, and I also want to rewrite this as one whole fraction when I do that. So the negative exponent will flip down to the denominator, so I'll have an a to the positive 8. B to the fifth will stay in the numerator since the exponent is positive. And then negative 1 over 4, I'm going to keep the negative sign on the top, and then the 4 should be in the denominator since it isn't the denominator of the fraction to begin with. And that will be our final answer then for part C. Okay, let's look at part D. Why don't you guys pause the video and try D on your own first, and then we'll check it together. Okay, as I look at example D, there's quite a few pieces here. We have 2x to the 6 over x y to the 4th. Well, the first thing I notice is I can simplify stuff inside these parentheses. So before I even worry about that negative 3, I'm going to make my life easier by simplifying what's inside those parentheses. When I have a power or a base divided by the same base, I can subtract the exponents, so I'd get 2 times x to the 5th in the numerator, since I have 6 minus 1, over y to the 4th still, and then that negative 3 is still on the outside. Now that the inside simplified all the way, I can distribute this negative 3 exponent to all the pieces on the inside. How many pieces will end up being raised to the negative third power? I will have 3 pieces. I'll have 2 to the negative third, we'll have x to the 5th to the negative third, and we'll also have y to the 4th to the negative third. Each one of these is going to be a little bit different. So 2 to the negative third, I can't simplify until I get rid of the negative exponent. But I'm going to do all the negative exponents at once at the end. So I'm just going to rewrite that part for now. When I have a power to a power, I can multiply them. So we get x to the negative 15th. Again, power to a power, I can multiply those and get y to the negative second. Now from here, we do want to go ahead and simplify all the negative exponents. So each one of these is a negative exponent, which means they're all going to flip places. So anything in the numerator with a negative exponent will be moved down to the denominator, and that will become a positive exponent. So I'll have 2 to the third, x to the 15th, and then anything in the denominator with a negative exponent, remember, gets moved to the numerator with a positive exponent. And that's our second rule here. And we talked about that a lot in part 1 of this learning target. From here, the last thing I have left to do is simplify what 2 to the third is. So I get y to the 12th over 2 to the third is 8. So we get 8x to the 15th then as our final answer for part D. Okay, let's scroll down and get enough space for part E. Why don't you guys pause the video and do part E on your own first? So again, in part E, I got quite a few moving pieces. I have x's on top and bottom, I've got some y's on top and bottom, and then I also have some z's now. So we've got 3 different types of bases. So that means I can group each one together. So x to the 4th over x to the 4th, y to the negative 1st over y to the negative 5th, z to the 8th over z, and now we can simplify each one of those. Anytime we divide power by power, we subtract the exponents when the bases are the same. So I'll get x to the 0, since I'll have 4 minus 4. We'll have y to the positive 4. So I'm going to write this one out for us just so we can see it. We have -1 minus a -5. And then we'll end up with z to the 7th, since we have 8 minus 1. And then that middle one we can simplify. Remember, -1 plus 5 would give me a 4 then. So don't forget about those double negatives. I'm almost done. I have no negative exponents, but I can simplify this a little bit more by dealing with the x to the 0. So remember, anything to the 0 power is equal to 1, so I'll replace that with a 1, and I end up with y to the 4th times z to the 7th. And that will be our final answer for part E. We can't simplify them and combine them together anymore since the bases are different. Hey, let's look at a couple more examples. So, why don't you guys pause the video and try example F on your own first, and then we'll check it together. Okay, let's check example F. So the first thing I notice is inside the parentheses, I can simplify stuff. The x to the 4th over the x squared can be simplified. We can also simplify the 3 over the 6. So I'm going to make my life easier by simplifying the inside down first and then dealing with that 5th power. So inside, I still have the 5th power on the outside, but inside, 3 divided by 6 would give me a 1/2, so I'll end up with a 2 in the denominator. The y squared will still be there as well, and then x to the 4th over an x squared, I can subtract the exponents, and I'll get an x to the positive 2 in the numerator. From here, I can now distribute that 5th power to all the pieces inside. How many pieces will that 5th power be distributed to? We will have 3 parts. We'll have the x squared to the 5th over the 2 to the 5th, and then the y squared is also going to be raised to the 5th power. The last thing I have left to do is simplify each one of these parts. X squared to the 5th means I can multiply the exponents because I have power to power. That would be rule 4 over here in our property of exponents. So I'll have x to the 10th, 2 to the 5th we can multiply out is 32, and then again y squared to the 5th, multiply the exponents, and I'll get y to the 10th. And that will be our final answer because I have no negative exponents and I have all different bases, so I cannot simplify any further. Okay, let's look at example G. So in example G, we have quite a bit going on, but it's actually really similar to example F, and here's why. Again, anytime I have a bunch of stuff inside the parentheses, I want to simplify that as much as I can before I deal with the outside exponent, because in the end, it's going to make my life easier. So let's figure out how many pieces we can group together on the inside. So I have an A, another A, and then an A to the 5th. We also have a B squared and a B, and then we have all the coefficients, a 2, a 6, and a 12. What I'm going to do first is just combine stuff in the numerator that I can combine together. So we'll end up with 2 times 3, which will give us 6. An A times an A would mean that I add the exponents. That would be our property number 3 over here. So I'll end up with an A squared. Then we'll still have the B squared, and then let's rewrite the denominator since the denominator was already simplified down as much as we can. So in step 1, we just combined what we could in the numerator. Check. Let's now see what we can combine between the fractions. So 6 divided by 12 would give me a 1/2. So I'll end up with a 2 in the denominator. And then I can subtract exponents here. So A to the 2nd over A to the 5th means I'll end up with an A to the negative 3rd because I'll have 2 minus 5. That would be our rule number 5 over here. And then I can do the same thing with b to the second over b. I can subtract the exponents. 2 minus 1 will just give me 2 to the first. I'm going to go ahead and move that 2 over to the center just since it's the only thing left in the denominator. Then don't forget we still have the 4th power on the outside. Now that the inside portion is completely simplified, let's go ahead and distribute the outside power to all the pieces. How many pieces will we distribute that 4th power to? We will distribute it to 3 pieces. We have the a to the negative third to the 4th. We'll have the b to the 4th. All over, we'll also have the 2 to the 4th. So, last thing left to kind of simplify is this a to the negative third to the 4th. I have power to power. This is property number 4 up here, so I multiply those and I get a to the negative 12th. B to the 4th is already simplified, and then 2 to the 4th is 16. The last thing left here to do is deal with our negative exponent. This would be property number 2 in our list of exponent properties. So anytime I have that negative exponent, I can flip it down to the denominator, and we'll get b to the 4th as the only thing left in the numerator over 16a to the positive 12. And that will be our final answer for part G. So although part G looked really complicated and there was a lot of pieces at the beginning, if we take it a step at a time and look how careful we are with showing our work and showing each one of our steps and our thought process, we're able to simplify that down. And simplifying the inside as much as possible first before dealing with that outside exponent can make our lives easier in the long run. Okay, I'm going to have you guys pause the video and tackle problem H on your own first. Remember, take it a step at a time, simplify as much as you can inside the parentheses, and then deal with that outside exponent. Okay, let's check H. So I'm going to go ahead and highlight everything I could combine together. So I've got all these coefficients, 2, a 4, and a negative 8. I've got the x's, so I have an x squared, x to the 7th, and an x to the 12th. We also have the y's, so we have a y to the 4th, y to the 9th, and a y squared. Let's start by just simplifying the numerator. So I'm going to rewrite the denominator since I can't simplify that by itself anymore, and just have that ready to go. And I'll also put the third exponent out there. In the numerator, I can multiply 2 times 4, which will give us 8. X to the 2nd times x to the 7th means that I can add the exponents because their bases are the same. That is our property number 3. So I'll end up with x to the 9th from 2 plus 7. I can do the same thing with the y's because their bases are the same and I'm multiplying them. I will add their exponents. 4 plus 9 will give us 13. So we've now simplified the numerator. The next thing we want to do is simplify between the fraction. Can I reduce the fraction down any more? So 8 divided by negative 8 would give me a negative 1. X to the 9th over x to the 12th, we can simplify because the bases are the same. So 9 minus 12 would give us x to the negative 3rd. Remember, we're subtracting the exponents because we're dividing their bases, so that's rule number 5. I can use that same property on y to the 13th over y to the 2nd, and we'll end up with y to the 11th. All of that in parentheses raised to the 3rd power still. Now that I've simplified inside the parentheses, I can go ahead and distribute the exponent to all the pieces inside. How many pieces would we distribute that exponent to? We would distribute that exponent to 3 pieces. The negative 1 to the 3rd, x to the negative 3 to the 3rd, and y to the 11th to the 3rd. So let's take these term by term. Negative 3, or part by part. Negative 3 cubed would give me a negative 1, so I'll have a negative sign. X to the negative 3 to the 3rd, I would multiply those and get x to the negative 9th. Likewise, I'll multiply the 11 and the 3 since I have power to power and get y to the 33rd. I've combined this as much as I can. Since x and y are different bases, I can't combine those any further. But what I do want to do is rewrite this so I have no negative exponents. So anything with a negative exponent will have to get flipped down to the denominator. How many pieces will I move down to the denominator? We will move one piece. We're just going to move the x to the -9th, and that will become x to the +9 in the denominator. The coefficient here, which is a -1, will stay in the numerator because its exponent is positive. So I'll end up with negative y to the 33rd in the numerator. And that will be our final answer for part H. Okay, from here, we want to look at our last example. So I'm going to have you guys pause the video, try example I on your own first. Remember, take it part by part. Work and simplify as much as you can inside the parentheses and then deal with that outside power. Okay, let's look at example I. So I've got -70, a to the 11th, b to the 8th, all to the 0, times a to the 3rd, b to the -3rd, all over -2, a to the 4th, b to the -7th, the entire thing to the 2nd power. Whew, wow, that's a lot. One of the things I noticed though right away is that 0 exponent. So this is going to be, remember, one of our favorite rules. Anything to the 0 power is equal to 1. So as complicated as this is in parentheses, -70, a to the 11th, b to the 8th, it is all raised to the 0 power, so this entire piece is just equal to 1. Well, that simplified stuff a lot for us then. So on the numerator, I'm just left with a cubed, b to the -3rd, over -2, a to the 4th, b to the -7th, and then yes, I still do have this whole mess to the 2nd power. But our numerator simplified down really nice just by remembering that anything to the 0 power is 1. And if I can simplify stuff right at the beginning, making our life easier. From here, I want to combine as many terms as I can. So the 1 in the numerator is technically 1 over -1/2. That will, or 1 over -2. So I'll still have a -1/2 in the denominator. A to the 3rd over b to the 4th. Because the bases are the same, I can subtract the exponents and I'll get a to the negative first. I can do the same thing with the b's because their bases are the same. So I'll get b to the -3 minus the -7. So be careful with those double negatives. We've seen them trick us before. All of that to the 2nd power. Now I'm going to just rewrite the b's. So I end up with b to the +4th, all of that over -2. Remember, it's +4 because I end up with -3 plus 7. Now from here, I can deal with my exponent on the outside. The inside is simplified as much as it can be. All that is left is that exponent on the outside. How many pieces will we distribute that exponent to? We will distribute it to 3 pieces. The a to the -1st, now to the 2nd, this b to the 4th, to the 2nd, all over -2 to the 2nd power. I'm going to finish this off down here, give ourselves a little bit more space. If I have power to power, I multiply them. So we get a to the -2, b to the 8th, and then -2 squared would be -2 times itself, which would give us a +4. Now that we've simplified it as much as we can, I can't combine the a and the b's because they're different bases. The last thing left to do is rewrite any negative exponents. So the a to the -2nd will move down to the denominator and we'll end up with b to the 8 over 4a to the 2nd. And that will be our final answer for example I. So as you can tell on these, we went through these 9 examples in this video that got a little bit more complicated each time. But remember, if you take it a step at a time and apply one property after the next, make sure your work is organized and clear for you to follow and understand, and then you'll be able to see that these problems aren't really as complicated as they might first appear.